All right, let's get right into it. We're going to talk about one of the biggest, but maybe quietest challenges in all of software engineering. And that is, what on earth do you do with mission critical code that's basically trapped in old, aging technology? Today, we're going to break down a real engineering first approach to modernizing this super valuable legacy software, but without all the chaos and the risk of a start from scratch rewrite. In this quote, right here, this is the absolute heart of the problem, isn't it? I mean, just think about the decades of business logic, all the unique rules, the countless special cases that are captured in systems for inventory or accounting or sales. The value in that logic is immense, but the technology it's built on, sometimes it can feel like you're trying to watch a brand new movie on an old black and white TV. The story is great, but the medium is just obsolete. So, when your most crucial business logic is stuck in old tech, think COBOL or RPG, you hit a very, very real wall. For one, the pool of developers who even know those languages is shrinking by the day. And you can just forget about the massive ecosystems like NPM or Maven that modern developers take for granted. Even simple things like integrating with a new cloud service become this massive headache. You're just slowed down, and your costs keep going up. Now, this is almost always the first reaction, the Big Bang rewrite. Let's just scrap it and start over. It sounds so clean, so decisive. But more often than not, it is a trap. And it's a trap that leads to two huge pitfalls that can derail projects for years or even kill them entirely. This table just lays out the difference perfectly. A monolithic Big Bang rewrite is a huge gamble. You're basically working inside a black box for years, almost always underestimating the subtle complexities that are baked into that old system, and you might never actually deliver any value. A structured pipeline, on the other hand, well, that turns the whole thing into a manageable, transparent process where you get these incremental wins all along the way. And okay, with the rise of AI, there's a new temptation, right? Just ask an LLM to translate it. But here's the catch. Large language models excel at creativity. They're amazing at writing a poem or an email, but that's the opposite of what you need when you're migrating millions of lines of code. You need deterministic precision. You need every single line to be transformed predictably, without any, let's call them creative and potentially disastrous detours. And that brings us to the engineering solution, using what are called algorithmic transpilers. The best way to think of these is like compilers. They take code in one language and they systematically transform it into another in a way that's predictable, transparent, and totally reliable. This isn't magic, it's a process we can actually design, test, and control from start to finish. Now, to really appreciate why this engineering approach is so important, we have to talk about a really common way these projects fail. It's called transliterated code. This is what happens when a migration is done poorly. The new code, it works technically, but it just feels completely alien in its new home. And Jabal is the classic, infamous example of this. You end up with Java code that is, yes, syntactically correct, but it's structured just like the old COBOL. It's full of these awkward, unmaintainable patterns, and that completely defeats the entire purpose of migrating in the first place. You were supposed to make the code easier to work with. Instead, you've just traded one legacy problem for a brand new one. So, this is the crucial point. This is the whole ballgame. A successful migration doesn't just swap out keywords. It understands the meaning, the intent of that original code, and it finds the most natural, idiomatic way to express that same logic in the new language. We're talking about translating concepts, not just characters on a screen. So how do you do that? How do you migrate intent? Well, you do it with a migration pipeline. Instead of one giant monolithic tool that tries to do everything at once, you break the problem down into a series of clear, verifiable stages. You start by just understanding the code structure, then you enrich it with meaning, you analyze it for patterns, you transform those patterns, and finally, you generate clean, new code at the very end. Okay, that raises a pretty obvious question though. If each of these stages is its own separate tool, maybe even written in a different programming language, how do you get them to talk to each other? How does the output of the parser become the input for the analyzer? And the solution is actually pretty elegant. You use a shared, open format that every single tool in that pipeline can understand. Think of it like a universal translator, but for code structure. This is what allows every component to communicate seamlessly, no matter how it was built. And a standard like LionWeb is what makes this whole thing possible. It defines a common way to represent the structure of the code, what engineers call an abstract syntax tree, or an AST. This means you can have a parser written in Java hand off its results to an analysis tool written in Python, because they both speak LionWeb.
And crucially, it lets you pause the pipeline at any stage and actually look at the code's intermediate form. This is what moves migration out of that scary black box and into the light.
This transparency is a game changer because it lets you track your progress with real, hard data. Instead of just relying on a gut feeling that, yeah, I think things are going well, you can have a dashboard showing that, okay, 98% of files are parsing correctly, 92% of symbols are resolved, and we're successfully transforming 85% of the old code constructs. It turns what used to be a risky art into a measurable science. So what's the big takeaway here? By treating migration as a true engineering discipline, you get these enormous benefits. Every single piece is testable on its own. Your components can be reused for other projects. The whole process is transparent. And maybe most importantly, it becomes a repeatable, reliable process you can trust, not some high-stakes, one-off gamble. This whole pipeline approach really reframes the conversation. It suggests that your legacy code isn't just a liability to be thrown away or a ticking time bomb. Instead, it's a valuable asset that's just waiting for the right process to unlock its full potential in a modern world. It offers a clear, engineered path to get there.